All right, let's give it a shot with this equation here. I mean, not equation, this example, 12.9. We've got a balloon, and we're only in two dimensions. We don't have a z here, we're just an xy coordinate system, but still curvilinear. We could do everything we've talked about. And it's asking us to find the magnitude and direction of the velocity and acceleration at time t equals 2. So we've got a function there, but it's y equals x, right? So that's not gonna, we wouldn't be able to just do the derivative of x squared over 10, right? Because that would not be y dot. That'd be something else, right? If we did that, what does it need to be if we want to do a y dot?
To plug in the function for x.
Yeah, it needs to be in terms of t first, and then we can do it.
60.
Yeah, you're getting there. There's also there's we can do it that way, or we can like plug it in and do the derivative. There's another way that avoids issues with unit non-homogeneity, which remember last time you were looking at it and saying, if I plug in seconds, it does not come out to meters per second or meters per second squared for acceleration, right? Sometimes that happens and it gets weird if we plug in x into the y equals x squared over 10 equation. We might end up with some funkiness. And so I'll show a way to avoid that. So let's start out though with the x one and we'll go to the y one because x is already in terms of t, right? So that's not too bad. We can say the velocity of x or x dot is just the time derivative d dt of the position function x. So d dt of x equals 8t. So the derivative of 8t is just 8. Mhm. Yeah,
The whole means like is the derivative.
exactly.
Two dots, that is the second derivative.
Exactly. Yep. And it's always the time derivative.
Remember? You saw the other day, EPQ, I was lost because like
Oh, really?
idea what he said, I was like, why there is a dot?
Oh, yeah.
It was tripping me up very minutes.
Yep.
I was so tired because that day I didn't sleep because I came here to the airport and everything and they picked me up like
Oh, yeah.
so I sleep the whole day.
That's
the class before and then that class.
that's a long day. Yeah.
I was there like falling asleep and then I saw the dot. I was like, nah, I don't want to see
Yeah. Yeah, that's what the dot typically means. For most of your calculus classes too, it'll be a time derivative. So good to figure that out. Okay, so we've got the time derivative of the position, we got the velocity. If we did the derivative one more time, what would it be?
Accelerate.
Yeah, what would the magnitude be? 0. So what does that mean about our x acceleration? It doesn't have any, right? So it's moving to the right, but it's not accelerating to the right. Which makes sense, right? The hot air in the balloon isn't going to make it speed up very much to the right? Mostly just up. So let's move on to the y component. So if we have the y dot, and we know that, well, we want to find y dot, right? So we have y equals x squared over 10. So if we do the time derivative of the y equation, we can't just do, 2x divided by 10. That would be if we did d dx, right? If we did the derivative in terms of x. But we're not, we're doing it in terms of time. So x is a function of time, right? And this is what I was saying. I'll show you how to do it and not get the units funky. So instead of plugging in 8t for x, we're just going to say x is a function. And it is a function that has t inside of it. So what happens if you do a derivative of a function that has your variable inside of it? Yes, we end up with a chain rule. So we've got this exponent. So that became 2x, but x was a function. And so we've got to say 2 times x times the derivative of x, which would be x dot.
Why is what's plugged in for X 16 and not 8T?
Yeah, we plugged in 2 seconds for X. Yep. Yeah, so that's what they're not explicitly shown here, but yeah, we've got 2x, that was our derivative, divided by 10, times x dot, that's the derivative of the inside function.
Function, then it would be 16T times 8/10.
Hmm.
Okay.
Yep. Yeah. So then we plug in what we know. So we know at 2 seconds, x would be 8 times 2 if we plug it into the x equation over here. Right? And so that would give us 16. They plug that in for x. And then we know at x dot, it's always 8 feet per second, right? It's a constant velocity. So we plug that in for x dot, all divided by 10. We got 25.6 feet per second going up.
How did we end up with that?
With,
Like, where did 16 come from?
so that's x,
And where
right?
did that-
And we know x is this function, and it's 8 times plug in 2 seconds.
2 specifically.
Right. Yeah, we're finding the magnitude at 2 seconds.
We plug in 2 for t, that makes sense.
Cool. Good. And they wanted the magnitude, so we've got the x component, the y component. Little Pythag gets us the total magnitude of the velocity at 2 seconds. So far, so good? Okay. Start thinking. Oh, and here's one last thing. We want the angle there for the direction of the velocity at that instant. So if you've got a triangle, right, y component on the right side, x component on the bottom side, solve for the angle. So I want you to start thinking now. We've got acceleration coming up that we need to find the magnitude at 2 seconds. So we've got an x dot and a y dot. We need an x double dot and a y double dot, right? And then we could get the magnitude of those added together. So we've got the x component. What did we say our x double dot's going to equal? Yeah, and we take the derivative of the constant 8 feet per second, going to be 0. So no acceleration, so our x double dot's 0. So we're good on that. But then we need to come up with the y component. All right, so there's our x component. Our y component, and the book's going to call it v dot, which that works too. Or you could call it y double dot, might as well. So now we're taking the derivative of what we got for y, the velocity y dot, right? So that was 2x x dot divided by 10. So now thinking calculus-wise, what do we need to do there? We've got a function times another function.
2x dot divided by 10. We don't like plug in the actual x function in there.
Right. Yep. Yeah,
Okay.
we're just like we did on the previous one. We didn't plug in the 8t. We'll do that after when we're just plugging in for x and x dot and x double dot. So if we have two functions multiplied by each other, what does calculus tell us we need to do for a derivative? Product rule, right. So how's the product rule little sing-song go? It's the first times the derivative of the second plus the second times the derivative of the first. Is that coming back? Sounding familiar? So we've got the 2, it'll just be on both of them, but then we've got the, they did this in the opposite, so they did the second times the derivative of the first plus the first times the derivative of the second. So here it is, the second would be x dot times the derivative of the first would be the derivative of x, so x dot. divided by 10 plus the first times the derivative of the second. Oh, and I'm pointing at my screen and you're not seeing it. So this is the derivative of the first times the second plus the first. I said it wrong. The derivative of the second times the derivative of the first plus the first times the derivative of the second. There it is. The derivative of the second would be the derivative of x dot, so it's x double dot. We all following along there? So it was x times x dot. So the derivative, so the second times the derivative of the first plus the first times the derivative of the second. Right? Product rule. So now we can plug things in and come up with our answer there.
Understanding this right, so like if we were evaluating this at a specific point in time.
Mhm.
In order to get that acceleration thing, we'd have to plug in t into x first, and then we plug all the x stuff into that equation.
Right.
Okay, that's complicated, wow.
So yeah, so that's basically what we'll do now, right? We already solved for x before at 2 seconds with 16 feet. So we plug in 16. X dot is always 8, right? So we plug in 8 for x dot. Oh, and I'm pointing at the wrong thing. So we've got 8 and 8 for our two x dots. And then 16 for this x. And what would x double dot be?
It's gonna be 0.
0, yeah. So this whole last term goes away.
Matter. Why is it 2 times 16 when x dot is 8?
X dot should be 8 times 8. Yeah, I don't like that. Oh, wait, no. That's 8 squared is this. Oh, I'm pointing at the wrong thing. Yeah, this is 8 squared. And then,
Why?
yeah,
8 times 2.
yeah, that's a mistake right there.
No, it's 8.
Is it not?
8 times 2 uses 80 x.
Oh, yeah, X was 16. Yeah. X dot was 8.
Oh, got it.
Yeah, so that's good. It's right. Uh-huh. Excellent. Okay, so we've got both components there. Find the magnitude, which is easy, right? Because we only have one component. Find the direction. What the heck? Does that make any sense? As an answer?
Like up.
Yeah, it's going straight up, so it would make sense that the angle is 90. Although this probably doesn't feel right math-wise. Divide by 0 and coming up with 90. Yeah. All right. We'll call it good there for this one.